Hi, welcome. We are doing 12.1 notes, which is on page 58 in your note guides. Did 11, 12. We're going to come back to chapter 10, I think, after this. Go ahead and make sure you put your date up there. We are going to explore some solids today. A polyhedron is a solid that is bounded by different polygons. So which of these right here are going to be polyhedrons? So a prism, triangles, squares, rectangles, yes, those are polygons. Pyramid, you have a square and triangles on the side. Again, all polygons, polyhedron. A cone, we have this circle here. A circle is not a polygon. Okay, a circle does not count because they're not like straight sides. Not a polyhedron. A cylinder, again, has that circle. I do want to show you this. If you were to take a piece of paper, right, and fold it up like this to make kind of a cylinder, right, the top and the bottom are circles, but if I were to cut it straight up and open it up, what shape is the face here? So the face right here is a rectangle, which is kind of a polyhedron, or not a polyhedron, but it's a polygon. So keep that in mind that when you were to open up a cylinder, that lateral edge, the lateral face, is going to be a rectangle. But in and of itself, not a polyhedron. A sphere, not a polyhedron. We have this theorem for any of our polyhedrons that have polygons for all their faces. It is called Euler's theorem. Euler's theorem is our faces plus the vertices equal the edges plus 2. So remember, the face in and of itself is the polygon itself. So like the top square right there. The vertex right here is just the point itself. So the vertex is actually just this point right here is the vertex. The edge is going to be the line segment. So an edge would be this right here is the edge. Okay, a regular polyhedron, all faces are congruent if it's regular. Okay, this one, is this one regular? No, it is not. You have some trapezoids, you have some rectangles. So if it were regular, however, all faces are congruent, regular polygons. Okay, so all of the faces would be all congruent and they would be regular polygons. So triangles, squares, regular hexagons, things like that. Is the solid down here a polyhedron? If so, we're going to count the number of faces, vertices, and edges. So right here, decide if it is. And I'm going to say yes, it is. All of the sides are polygons. So I want to check this formula over here. This is going to be a formula that you want to remember. Oh, I forgot to tell you how to remember it. Okay, do you see like that it almost looks like a word? Anybody see that it almost looks like a word? We call this formula 5 plus 2. So 5, F-I-V-E, right? Kind of like 5, you don't have the I, but F-V-E, 5 plus the 2 at the end. That helps me remember it, so if there's a lot going on up there, I remember it by 5 plus 2. So I'm going to set up my 5 plus 2. Count how many faces do we have. Now this one's kind of like a tissue box. You have a top and a bottom, 1, 2, and then you have 3, 4, 5, 6 laterally. So here we have 6 faces. Go ahead and take a tissue box again. All of the vertices, the points, I have 1, 2, 3, 4. And then I have 5, 6, 7, 8. That's all the points that I have on this rectangular prism is what it is. But I have 8 vertices. Now then you have to ask yourself how many edges do you have. So on the top I have 1, 2, 3, 4 edges. On the bottom I have 1, 2, 3, 4. That's 8. On the side I'm only going to count these 2 because I already counted the top and the bottom. So I have 8, 9, 10, 11, 12. So right here I have 12 edges plus that obligatory 2 out here. 6 plus 8 is 14, equals 12 plus 2, which is 14. So check, that formula worked. Here's a polyhedron, and there we go. Now over here, first decide, is it a solid? Is the solid a polyhedron? And no, this one is not. Oh, sad face, sad face. This one is not, because it has this like curved cylindrical edge. These are decahedrons. What do you think deca means? Deca means 10-sided polyhedrons. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. Is the decahedron convex or concave? Oh, sorry, convex or non-convex, meaning concave. So convex is if something were to roll off it. Concave is when it caves in. I think we've talked about these before. I always think if there was rainfall, would rain puddle anywhere? And here it would fall right off of it. Even if I turned it somewhere, this would fall right off of this. There's not going to be a holder of it. So this one is going to be convex. And now I have to decide, is it regular? Are all the sides the same? Well, all of the faces are isosceles trapezoids. All the faces on the top, all the faces on the bottom. But the very top and bottom are probably squares, I think. They're not all the same. If they are not all the same, it is not regular. For a minute, you want to say that one's regular, so it's tricky. Over here, so again, convex or concave. Now I just talked about water, and well, obviously there's not going to like hold it, but can you see that water would fall in and it could hold in that area? So I think if it's going to fall in and could be held in like a puddle or something, this is concave, it caves in. So concave or non-convex. Now, is it regular? So again, no, this is some U shape, this is a rectangle, this is a square. They're all different types of figures, so not regular. Okay, a cross section. A cross section is the figure created by the intersection of a plane and a solid. So kind of like I have this Rubik's Cube here. If I have this Rubik's Cube and I were going to cut it across, like, or sometimes I think if you had a cube of cheese, you know how sometimes you get like party trays and there's like a cube, a perfect cube of cheese. If you were to take a knife and slice that cheese diagonally across the diagonal, right, you're going to end up with triangular prisms that you can take off. So that's what a cross section is. If I can cut a piece of that polyhedron and take it away. Describe the shape that's formed by the intersection of the plane and the cube. So I like to shade it in. If I were to do this and I were going to take apart that cube, what face is going to be like visible to the air? What face would now, what's the new face that's going to have air touching it? And it would be this right in here. If I were to cut that cube of cheese, I would now have this shape visible to like the elements. This shape is a rectangle. So what is, if I take another cube and then I slice the edge here, I do another kind of triangular prism, but this time it's different. I'm cutting off like a little corner. Now I'm going to have this little piece visible to the elements, visible touching the air. That shape is still like a little rectangle on the corner. Now this one is a little bit like if we had this and it were slanted a little bit. So not directly diagonal, not the corner, but slanted a little bit on that edge. Now I'm going to have this piece. This is my cross section that is now open to the air. Now what type of shape do we see here? This one is a trapezoid. Parallel lines and non-parallel sides. This one will be a trapezoid. Okay, I'm going to go to the next page here. A solid has 10 faces, 4 triangles, 1 square, 4 hexagons, 1 octagon. How many vertices does the solid have? Now, live in class, I would have you work this out and show me what answer you get. I would give you some time. Pause this video, work this one out on your own, see if you can figure it out. Now, one of my common mistake answers, what's my common answer? I don't remember what's the common mistake. So we have to kind of think about this. I have all of these polyhedrons are faces. I have 4 triangles. I have 1 square. I have 4 hexagons. And I have 1 octagon. So I gotta ask myself, if I have a triangle, how many edges does that have? So if I have 10 solids, 4, 5, 9, 10. There's my 10 solids. How many edges does the triangle have? The triangle each has 3 edges. The square has 4 edges. The hexagon has 6 edges. The octagon has 8 edges. So really, this ends up being 12 edges here, plus 4 edges here, plus 4 times 6, I get 24 edges here, plus 8 edges. Add these together, 36, 40, 48. Here's my common mistake. How many of us say, okay, there's going to be 48 edges, which means there's probably going to be half of that, so 24 vertices, right, 24 points. And that's probably the common mistake. But let's go ahead and use our 5 formula, okay? Let's say we have 5. FV equals E plus 2. I know how many faces I have. I have 10 faces. I know, do I know? I want to know, vertices is what I want to find out. So vertices is going to be my variable. That's my question. I just said I had 48. Do I have 48 edges? Think about this. If I look at this, I had 1, 2, 3, 4, 5, 6 faces. 6 faces that were all quadrilaterals. So 6 times 4 is going to be 24. And if we look back on this, did I say we had 24 edges? And no, we didn't. We had 12 edges because each edge is shares 2 sides. So this edge is part of this face and part of this face. So I don't have 48 edges. I actually have 24 edges. I have half the amount. Now I can figure this out and solve for my vertices. So I have 10 plus V equals 26. Subtract, I end up with my vertices is equal to 16. And there we go. So you see there's lots of mistakes you can make in there. You want to be really careful. Some quartz crystals are pointed on both ends and have 14 vertices and 30 edges. How many faces does each crystal have? So again, set up your 5 plus 2. I want to know how many faces this time. Faces is my question, so this is my variable that I'm solving for. It tells me that I have 14 vertices and I have 30 edges. So it tells me those. I don't have to figure out how many edges. Faces, I'm going to have faces plus 14 equals 32. Subtract, I get my faces are equal to 18. Here I have a paper model of a geodesic dome. It is composed of 180 triangular faces. How many vertices does it have? So again, we have faces plus vertices equals edges plus 2. I have 180 triangular faces. That's 180 triangles, which means each of those triangles has 3 sides. Well, remember that if I do that, I'm going to get a number that's bigger than the actual number of edges. If I'm looking for my edges, I want to take this, and I know that I share one face. Two faces share one edge. So I'm going to divide this in half. Well, 2 goes into 180, 90 times 3 gives me 270. I have 270 edges. I have 180 faces. How many vertices is my question? So go ahead and solve for your V. I'm going to subtract over. I end up with vertices equal 272 minus 180. I get 92 vertices. There we go. Okay, so the next thing we're going to talk about with solids is platonic solids, the 5 regular polyhedra. Here are the names. I never ask you for these. I don't know when you would be asked for them. After a certain point, and maybe if you're like Big Bang Theory, you might know some of these names. Other than cube, we would know cube, and maybe tetrahedron. These aren't ones that you're going to really know, and I'm not going to ask you or test you on these. But equilateral triangular faces, platonic solids, the 5 regular polyhedra. 4 faces, 8 faces, 20, and they're equilateral triangular faces that you could have. A cylinder is intersected by a plane. Which shapes are possible for the resulting cross-section? I'm going to pause and draw some cylinders. Some of us want to see drawing of the cylinders. And I know a lot of you speed up the videos. Oh, I didn't want that straight line. A lot of you speed up the videos anyway 4 times. So you can either speed this up at double the time, or you can follow along. So I do 2 sides, and then I make kind of a circular bottom. There we go. And over here. Keep drawing like a rectangle. This is why I pause, because I want to see this. Okay, so now I want to draw a cross section that goes through it. So I could have a cylinder and I could cut it straight in half. I could cut it right down the middle. And here my cross section would be a circle. I could slice it right down the half right here and kind of create this rectangle. Or if it were as tall as it was wide, it could, if the, I don't know, it says the diameter. If the diameter is equal to the height, it could be a square. But you would have to know that those are equal. The next one we have, we could kind of cut this down at a slant. And I think we had these notes just the other day, parabolas. So we could have things that were parabolas. We could do this at a slant where it cuts both sides. And if it's tilted, so I would have a parabola up here. Down here, I would have an ellipse. Okay. We have one review problem here, and then we are done with our notes. F of x, you just did parabolas. I'm pretty sure the other day we did them, we skipped them. Parabolas, you have to ask yourself first, does it open up? So how does it open? When you are asking yourself how it opens, you are looking at your A value right here, and that tells you whether or not it opens up or down. So you have to look at if A is positive or negative A. Well, A right here is negative. This parabola opens down. The next thing is my vertex. So it's going to open down like this. My vertex is an ordered pair. My y-intercept is an ordered pair. And my axis of symmetry is x equals the number, the axis of symmetry. I color code these. So I'm going to use pink, green, and orange. I am going to tell you that my vertex right here, the x-coordinate of my vertex every single time is the same as my axes of symmetry. I find the x-coordinate of the vertex, I use negative b over 2a. That's part of like your quadratic formula. Negative b plus or minus the square root all over 2a. This is part of your quadratic formula. Negative b over 2a, let's see this, negative b would be negative 3 over 2 times negative 1/2. This is going to be 1. I get negative 3 over 1. Negative 3 over negative 1 is going to give me a positive 3. My x-coordinate of the vertex is going to be a positive 3, and my axis of symmetry, x is equal to 3. Which means I can go right now and draw that line. So I'm going to go over here to where x is equal to 3. X is equal to 3 at 1, 2, right here. Which means the line wouldn't go horizontally, it's going to be a vertical line. I should do this pink because I did that in pink. This is my axis of symmetry that my parabola is around. Okay, now the y-intercept, what's nice about the y-intercept is that x right here is always going to be 0, and I need to figure out this point right over here. My green, I didn't finish this one, but my green is going to be this, my vertex point, my y of my vertex. So what's really nice is if I'm going to plug in 0, 0 plus 0, I'm going to get that c, the 4. It's going to be my y-intercept. So I could plot this right away as well. I could go 0, 4. 0, 4 is up 1, 2, 3, 4 right here. And because I know parabolas are symmetrical, I know that if I go over 1, 2, 3, go over another 1, 2, 3, that's going to end up in the same spot of it. So that's pretty nice. Now, I also know that the vertex should be the middle of my t-chart here. So I'm going to put my vertex right here. I am going to figure out what my y-coordinate is. My vertex is 3. So I can go ahead and plug this in. 3 squared is 9. Divided by 2, this is ugly. I mean, negative 4.5. Three plus 3, I get 9. Plus 4. I end up getting 8.5 here. Now, that's ugly, not really pretty, but the nice thing is that you would only have to get a fraction on that one point if it were going to happen. You can choose points for the others where you're not going to end up with fractions, so that's nice. So I know this is going to be at 3, 1, 2, 3, up 8, 1, 2, 3, 4, 5, 6, 7, 8.5. I'm about right here. Okay, now what I want to do is I want to pick numbers that I can square around 3. If I go 2 squared, I can take half of that. That's going to work. If I do 4 squared, I can take half of that. That's going to work. I'm going to pick 2 and I'm going to pick 4. Now if I do 2 squared, I get 2 squared is 4 divided by, I get negative 2. 2 times 3, I get 6. Plus 4, I get 10. Minus 2, I get 8 here. What's really nice is that this is going to be the same as this one down here. So if this right here is 8, this one down here is also going to be 8. I don't even have to plug it in. I just know it's going to work. Because if I go 2, 8, I know it's going to have to be in the same spot. So can I pick 1? Because here I'm from 3, I went to 2. Can I pick 1? Well, 1 squared is 1. I'm going to have a fraction, so I don't want to do that. Could I go over one more and pick 0? Well, sure, I can pick 0, but I already know 0. I already know 0 is 4, which means this is 4. So I don't really have to pick that because I know it. What if I pick negative 1? Will give me a fraction. What if I pick negative 2? Negative 2 might be a good one to pick. So negative 2 would mean that I also go out to 4, 5, 6, 7, 8. I'm going to go to 8. 2 to negative 2 is 4. 4 to 8 is 4. There we go. This point right here was 8.5. I didn't write it in. Okay, let's say we do negative 2 squared is 4. I'm going to get negative 2 again. 3 times negative 2 will be negative 6. Plus 4, I get 6. 8, negative 8, plus 4, I get negative 4. And again, if I know that's negative 4, I know this down here is negative 4, so I don't even have to do the work. Negative 2, down 1, 2, 3, 4. And I know it's symmetrical, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And here we go. And I have a beautiful parabola. They're kind of tricky to graph. Out here. Can't really use a ruler, you gotta curve it a little bit. But there we go, there's our beautiful parabola. That is it for today's notes. I will see you next time. Have a fabulous day.